Hi there. We're just finishing off today what we started yesterday with the quadratic formula. We looked yesterday at the quadratic formula, and this is a formula that we should memorize, and hopefully we've got it memorized after our practice yesterday. And there's a special part of the quadratic formula that we're going to focus on today, and it's the part that is underneath the radical. Not including the radical, but that's underneath the radical. And that's called our discriminant. So we should have the front of our notes filled out. Let's fill out the back of our notes and take a look at this. In the quadratic formula, this expression, b squared minus 4ac, is called the discriminant of the associated equation, ax squared plus bx plus c equals 0. So again, the discriminant essentially isn't anything new you have to memorize, okay? The discriminant was what's underneath the radical in the quadratic formula, okay? So the discriminant is already something that you should have memorized based on our work with the quadratic formula. And so now there are just some special things that we can tell about our discriminant. So let's let D be our discriminant, which again is b squared minus 4ac. Well, it turns out that if your discriminant is positive, then that means that you're going to have two real solutions. And what happens is that if we're graphing, like if we replace the 0 that we had with y, what we end up with two x-intercepts on our graph. Now there's also sometimes when our discriminant is equal to 0. And if our discriminant is equal to 0, that means that we'll have one real solution. So that was, for example, on the your turn number 2 from the front side. That one, our discriminant was 0. And notice that we didn't have two different solutions. We just had one solution. That was a real number. And what happens is that if we were to replace the 0 with y and graph it, notice that we only have one place where it would intersect the x-axis. So there are also cases where the discriminant is less than 0. When the discriminant is less than 0, that means you're going to be taking the square root of a negative, much like you did in example 3 on the front. And in this case, what happens is that there aren't any real solutions because we have the imaginary numbers, but instead we have two imaginary solutions or two complex solutions. And our solutions correspond to the x-intercepts, and so notice if there aren't any real solutions, there are going to be no x-intercepts in those questions. Okay, so just kind of thinking about the graphing we did before and these solutions, that's why some graphs intersect the x-axis twice, once, and 0 times. So in example 4, it just asks us to find the discriminant of the quadratic equation and then give the number and types of solutions of the equation. Well, remember, we can't find the discriminant or use the quadratic formula unless our equation's equal to 0. But look, we have that all set for us in this example, in example 4. So we're going to find the discriminant. Again, our discriminant is when we have b squared minus 4ac. Our b is our coefficient of x, which is 4, minus 4, and then times a, our coefficient of x squared is 2, and c is negative 4. Make sure you're careful with the signs. And you can just put this whole thing in the calculator, or you could see that this is 16, and this is going to be a plus 32. So our discriminant value is 48. Notice 48 is positive. So since 48 is positive, this tells us that we're going to have two real solutions. And that's all that we are really using our discriminant for. It just tells the number and types of solutions. So in letter B, I need to get one side equal to 0 before I utilize the discriminant. So I would need to subtract 24 from both sides and add 4x to both sides. Let's make sure that we're only combining like terms. That was an issue yesterday. And I have 3x squared plus 12x plus 12 equals 0. Again, it's asking us for the discriminant. It's not going to hurt if you write what it is, especially since that's part of our quadratic formula. So to find our discriminant, we're going to take b squared, our b is 12, minus 4 times a times c. My a is 3, my c is 12. And we can put that in the calculator, or we might see that this is 144. This is 12 times 12, that's 144. 144 minus 144 is going to be 0. And so my discriminant is 0. If my discriminant is 0, that doesn't mean there's no solution. It just means that instead of two solutions, there's just one solution instead. So there's one real solution. Let's make sure people know that it's a real solution, and that way they'll know that they can find some x-intercepts as well. In letter C, I know we each have our preferences, either just moving one thing over or keeping everything, or keeping the leading coefficient positive. I really think it's a great habit to keep the leading coefficient positive. So I'm just going to move the rest of these over. You could do it the other way where you subtract 8x squared. You'll get the same discriminant, okay, as long as you have one side equal to 0. And so now that one side's equal to 0, I'm going to use that discriminant b squared minus 4ac to help me find the number and type of solution. So our discriminant is b squared, so negative 9 squared, minus 4 times 8 times 11. And then that's 81, and then minus 32 times 11, I don't know what that is. But if you put that in the calculator, remember to make sure that you put it in the calculator with the parentheses in it. So like if you're putting this in, you guys, make sure you put negative 9 in parentheses. So important. And so we end up getting that our discriminant is negative 271. And we see that when our discriminant is negative, that doesn't mean there's no solutions of any kind. It just means that we're going to have two imaginary solutions. Let me write the whole word so we know that imag isn't a different thing. Okay. All right, so two imaginary solutions, and there we have it. Okay. So one last thing, because this concept's pretty nice and easy today, and the problems are pretty quick. I just want us to review the idea of the vertical motion model. Remember that this can be used when an object is dropped, and when it's dropped, we said the velocity is 0, or launched or thrown. And in those cases, that means that there's going to be a different velocity. So in example 5, it says a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial velocity of 40 feet per second. Write a model for this situation. Well, when we're modeling, we need a couple different things. When we're modeling the situation, that means we need something for the initial velocity and for the initial height. So because the ball leaves the juggler's hand 4 feet above the ground, that tells us where it started. That tells me my starting height is going to be 4 feet. And this initial velocity of 40 feet per second tells me what my initial velocity is. And so in the model, all you're doing is you're putting those two things in. Your h of t is still your output. This -16 is always the coefficient on Earth. It's a gravity constant. And if a juggler is juggling, by the way, he's throwing it upward, we hope. So that's why we're going to have a positive velocity. So we're going to have plus 40t, and then plus h sub 0, which is our 4. So that's the model for this situation. It's not too bad. So now next it says that the juggler catches the ball when it falls back to a height of 3 feet. How long is the ball in the air? Well, remember, if the ball was hitting the ground, then our end height would be 0. But what's happening is that if it falls back to a height of 3 feet, that tells me that my end height, h of t, is going to be 3. So now let's put that into this equation. 3 equals -16t squared plus 40t plus 4. And it wants us to solve algebraically. And so let's solve using our quadratic formula. To do that, though, we need to get one side equal to 0. So I could subtract 3. And now I have one side equal to 0 so that I can use the quadratic formula. Again, I don't like the negative. I'd get rid of it, but I know this is still new for you guys, so you'd probably leave it alone. But we can use the quadratic formula. Remember our quadratic formula from yesterday. Instead of x equals our variables t, so I'll do t equals -b plus or minus the square root of b squared minus 4ac all over 2a. The other day, a lot of us were dropping this plus or minus between. That's bad plan, kiddos, okay? So make sure you have that. And then we'll substitute these values in. So I have -b, so -40, plus or minus the square root of b squared minus 4ac. So 40 squared minus 4 times 6, -16 times 1, all over 2 times -16. Okay, so I'm going to clean that up a little bit. -40 is just -40. If I simplify this and find my discriminant, if I take 40 squared minus 4 times -16 times 1, I get 1664. And then 2 times -16 is -32. Now, I've got, I think, maybe some good news for you. I know in the other problems that we did, when we're actually solving algebraically and we want an exact answer, we would need to simplify the radical, etc. But because this is a real world problem, we want to convert this to a decimal because it's a real world problem. Because, I mean, in reality, we don't say things like, oh, it took me, 2√2 minutes to do this, So it's good to be exact, but when we're just talking about a real world situation and we're reporting back, we want to make it more understandable. So that means that, okay, I think that worked. I pressed pause on purpose, or on accident. Sorry. Anyway, how else could we solve this equation? Well, another thing that we could do is we could look at different ways to solve this equation. If we thought about square roots, we wouldn't want to solve using square roots. We've got a bx term. I wouldn't complete the square because that is going to involve some yucky fractions. Factoring isn't really going to be a possibility, is it? And it just looks a little messy. And because we had these decimals, that wouldn't have worked anyway. So another thing that we could do is fall back and utilize what we did with technology. So I just want to recall what we did a while ago with the technology. So one of the other things that we could do is we could put y1 equals one of the sides of the equation, so negative 16t squared plus 40t plus 4, and y2 equal 3. So notice that we have one side of the equation in y1 and another side in y2. Or you could have that in y1 and that in y2, whatever, okay? And then we could find the intersection point. So we practiced that, I believe, in 1B4. And so using that in 1B4, you can have the, look at how you could find the intersection point. And there'll be two at negative 0.023 and at 2.52, 3. But obviously, we'd only use the positive answer, okay? So hopefully that gets you started and you can do some great work with our discriminant and the vertical motion problems. And I'll tell you another secret about the discriminant when I see you next time. Okay, have a good one.